Welcome to section 4 of the course titled Efficient Java Multithreading Using Executors to Do Everything That You Can Do with Threads. Till now, in all the tutorials, whenever we have run a task in a separate thread, it has run without returning a value to the main thread. In this section, we will see how to return values from threads. Now, the first thing to understand and remember here is that it is always the tasks that return the value, not the threads. Although in general parlance we do put it like returning value from a thread, but a thread is just a construct that drives a set of instructions separately in an independent flow of control. That set of instructions is called a task, and it is the task only that can return a value. That being said, there is no explicit language level support provided by Java to return values from tasks driven by normal threads using the Threads API. But Java does provide such support if you use the more modern Executors API. However, we can still get values back from the tasks that are executed by normal threads in indirect ways. There are a few ways to do that. Let us look at the first way. I have a skeleton class here by the name of returning values first way. As for the task, as none of our previous tasks return a value, we have to create a new task here. Let us call it value returning task A. As part of the task, we will emulate a long-running calculation by making it sleep for some specified duration. And as the run method does not accept any parameters, leave alone returning a value, we will have to accept the parameters here through the constructor. We are going to take in two integers and return their sum. We will also take in the duration for which the task should sleep in order to emulate long-running calculation. We also have to provide identity to the instances of this task. So let us do that too, in the same way as we have been doing before. Now let us put the main task logic in the run method. Now, how do we return this sum to the caller? The run method does not return anything. Let us put in a getter for that. Do you think it will work? Well, let us see. We are going to execute 3 instances of value returning task A in 3 different threads. And as we need to call the getSum method on the tasks later to retrieve the results, we need to capture the task references before we submit them to the threads. The class is ready. Let us run it now. It should be t3.start here. Okay, all the 3 results have come out to be zeros, which is wrong. So let us analyze the output here. The results are being printed even before the threads have finished executing the tasks. You can see that all the done sysouts appear after the result sysouts. That means the getSum calls were made before the tasks had finished their calculations. At that time, the value of the sum variable in all the 3 tasks was 0, which is the default value given to an integer class variable by the JVM. So we need a way here to let the task finish first, and after that only it should return the result to the caller, even if the caller has made the call to the getter method before that. So how do we do that? We use the wait and notify mechanism provided by Java. Inside the getter method, we make a check for whether the task has finished or not. If it has not finished, then we need to suspend the calling thread till the time the task is finished. First, let us put in the check. So we will create a Boolean variable done. As this variable is going to be read and written to by different threads, we need to make it volatile also, so that its values are read accurately by reader threads. Okay. After the task is finished, it should set the value of done to true. As a wait method can only be called from within a synchronized context, let us synchronize it on the current object only. And let us also put in a message here saying that the calling thread is waiting. Now, if a thread is waiting, then some other thread should also put it out of its waiting state. So, as soon as the task is finished, it should notify all the waiting threads of this fact. While notifying, it should again be synchronized on the same object, that is this. And let us also put in a sysout for when the caller thread wakes up. Okay, running the code now. There, our results have been printed correctly now, and let us analyze the output. We see that the main thread is put in wait state only for the first task. And after the first task is done, it wakes up and prints out the result from the first task. The results for the second and third tasks are also printed out immediately after the first task is done. So why were the second and third tasks not put into wait state at all? The answer here is timing. You see that the first task sleeps for 2000 milliseconds. whereas the second and third tasks sleep only for 1000 and 500 milliseconds respectively. So by the time the first task wakes up from its sleep, the second and third tasks had already woken up from their sleeps and finished the calculation. After finishing their calculations, they had set their done variable to true. So when the main thread reaches the statement where it calls the getter on the second task, it does not go into wait state and gets the result immediately. Same for the third task as well. Now, what if we reduce the wait time for the first task to 100 milliseconds? In this case, the main thread will first enter wait state for the first task. After the first task is done, the main thread will come out of the wait state and get the result. Then the main thread calls the getter on the second task. As the second task has more sleep time, it will still be executing. So the main thread should enter into wait state for the second task too. While for the third task, it should get the result directly without waiting. So let us run the code and see. Okay, the main thread has entered into the wait state here for the first task, and here the first task is done and the main thread has woken up and it has printed the result for the first task. And then the main thread has entered into the wait state for the second task here, and once the second task is done, the main thread again wakes up and prints the result for the second task. After that, it immediately prints the result for the third task without going into the wait state. So our hypothesis was correct. Now you see that even though the third task had finished earlier than the second one, its result was still printed at the last. If the main thread gets stuck on waiting for result from a task, the results from the subsequent tasks also cannot be processed till the time the main thread comes out of its waiting state. In other words, the results are processed only in the sequence in which we have coded to retrieve the results. In our current example, we are retrieving the results for the first task first, then the second task, and lastly the third task. Now, what if we want to process the results from the tasks in the sequence in which they are completed, rather than the sequence in which we are retrieving the results? This is the topic of the next tutorial. So stay tuned and bye. See you in the next video.